Hello everyone. In this video we are going to discuss the problems on correlation coefficient. How to find out the correlation coefficient for the following data. Here x is the independent variable and y is the dependent variable. For this data, firstly we have to find out the number of data points given in the question. We have 5 x values here, therefore it is n is equals to 5, and then the mean of the x series, which we represent it as x bar, can be obtained by adding all the values of x and divided by the number of data points n, which is 5 here, which on simplification gives you 15 divided by 5, which is nothing but 3. Y bar is equals to, same way, 2 plus 5 plus 3 plus 8 plus 7 divided by 5, which is 25 divided by 5 gives us 5. Next we prepare the following table where we have xi values, and capital Xi can be obtained by taking the subtraction of each value of x from x bar. Next, squaring of these values, that is capital X. Now we'll take y value, capital Y represents each value of y will be subtracted from y bar. Next, squaring of that values of y and the product xi multiplied by yi. We know the data for x, it is 1, 2, 3, 4, 5. And next, capital Xi is nothing but each value of x is subtracted from x bar. The value of x bar, mean of the x series, is 3. 1 minus 3 will become minus 2, 2 minus 3 will become minus 1, 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2. Next, each value of this x which we got it now will be squared. It will be 4, 1, 0, 1, 4. And we need the sum of this also. Therefore, when I add this values, it is going to be 10. Same way, y values, which is given in the question, as 2, 5, 3, 8, 7. Now each value of y will be subtracted from 5. 2 minus 5 is minus 3, 5 minus 5 is 0, 3 minus 5 is minus 2, 8 minus 5 is 3, and 7 minus 5 is 2. And now each value of y will be squared. It is 9, 0, 4, 9, 4. When we sum these values, it is going to be 26. Now the product, capital X will be multiplied with capital Y, minus 2 with minus 3 will become positive 6. Next, 1 with minus 1 with 0 will become 0, 0 with minus 2 will become 0. Next, 1 will be multiplied with 3 becomes 3. Next, 2 will be multiplied with 2. It is going to be 4. So when we sum this, it is going to be 13. This is what we have the values for summation xi square, summation yi square, and summation xy yi. Now let us substitute this in the formula. That is, r is equals to summation xi multiplied by yi divided by square root of summation xi square multiplied by summation yi square, which on simplification by substituting the values to xi, yi under with summation gives us 13 divided by square root of 10 into 26, which will be 13 divided by square root of 260, which on simplification gives you a positive value 0.8062. This is the correlation coefficient. There is an alternate method to solve this problem. We'll take the alternate method to solve. That is, by taking the values given to us for dependent and independent variable x are 1, 2, 3, 4, 5. Correspondingly, we have the dependent variable value, it is 2, 5, 3, 8, 7. Let us sum all the values of x and values of y. Summation of x gives you 15, summation of y gives you 25. Now each value of x will be squared. It is 1, 4, 9, 16, 25, and when we sum this it is 55. Each value of y will also be squared. It is 4, 25, 9, 64, 49. On adding all these values we are going to get 151. And now the product of x and y are considered here. It is 2, 10, 9, 32 and 35. When we add all this, it is going to be 88. Now we have taken the alternate formula for finding r, that is n into summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x whole square, and same way n into summation y square minus summation y whole square. So if I substitute the values, summation xy is known to us, summation x square, summation y, summation y, summation x, and all these values on substitution and simplifying here gives you the same result as the previous one, which is 0.806.